Here we go. We have a question, construct the smallest number from di string. So you have given a zero index string pattern of length n consisting of the characters either I means increasing or d means decreasing. A zero index string num of length n plus 1 is created using the following condition. So we have to create this num using the following conditions. So we have given 3 bullet points. Num consists of digits between 1 to 9 and each digit is used at most once, max to max once. If ith character of pattern is I, it means we have to add the number in increasing order, or if this is d, we have to add the number in decreasing order, and we want to return the smallest possible string. So suppose we have given this pattern, so it contains I and d only, and we have to create this. So we can start from any first character, either 1 2 3 4 5 6 7 8 till 9. Then the next is I, so the next character must be greater than the previous. Then next is I, it must be greater than previous. Then this, it must be greater than previous. Then d, it must be greater than smaller than previous. Then I, so 9 is greater than 4. Then d, 8 is smaller. Then d, 7 is smaller than 8. Then d, 6 is smaller than 7. So this is the smallest string, smallest possible string of length, pattern length plus 1, that satisfy all these three rules. Then for this example, for this test case, we want to create d, d and d. So we start our string from 4, then we will add 3, then 2, then 1. So I will consider, I will take this example and I will explain you how we can solve this question. So let's build the approach. So I will take I, D, then I, D, D and D. So I have choice between 1 to 9 and I can start from any character. So if I start from 1, so I also have a, like we can say, a set, so which will track how what are the characters that we have already used between 1 to 9. So first I will start from 1, then this is increasing, so I will put 2, because first of all I will try to put 1 here, but 1 is already used, so I will put 2 here which is not used. Then next character is still I, so we must use the next character that we have not used. 1 is used, 2 is used, so we will use 3. Next is I, so 1 is used, 2 is used, 1 used, 2 used, 3 used, so we will place 4 here, and 4 satisfy the increasing order and it is also not used. Then we will try to place a character with decreasing. So here 1 we cannot put, 2 3 4 we cannot put because already used. Then 5 we cannot put because we want to do in decreasing order. So this is increasing, but we want to do decreasing. So 5 6 7 8 9, any value cannot be put, non value cannot be put. So then previously we have put 4 here, then the remaining string we cannot make, so it's time to do backtracking. We will put 5 now, and we will put 5, so we have fulfilled this I, and this I. Now it's time for D. Can I put 1? No. Can I put 2? No. Can I put 3? No. Can I put 4? Yes, we can put 4. So I will put 4. So I have fulfilled this D also. The next is I. Can I put 1? No. 2 no, 3 no, 4 no, 5 no, 6 yes, 6 we can put. This is increasing, so we have fulfilled this also. The next is decreasing. Can I put 1 no, 2 3 4 5 6 7 8 9? None, we cannot put anything. So then we will do backtracking, then we put 7. So I till I we have fulfilled. The next is D. So 1 2 3 no, 4 5 no, 6 yes, 6 is yes. Then next is till D. Between 1 2 3 4 5 6 7 8 9 we cannot put anything, so we will do backtracking. We will try to put 7, but 7 is already used on this, so we will try to put 8. So 1 second. So sorry, previously we have used 6 here, so then we will try to put 7, but 7 is already used. We are trying to make decreasing. 7 is already used. 8 we cannot put because we are on to D. We want to fulfill this D. We cannot put 8 9 10, so it's time to backtrack again. Then we will put 8. So this increasing, till increasing it is fine. Then we are on to this decreasing, so we are fulfilling this D condition. Can I put 1 no, 2 3 4 5 6? 6 we can put, so we will put 6 here. So this decreasing is already is fulfilled. Then D is, then again D. 1 2 3 4 5 6 7. 7 no, 7 no, 8 no, 9 no, 10 no. So we will do backtracking. We will try to put 7. So we have fulfilled this. Then the next D. 1 2 3 4 5 6 7 yes, 6 we can put. So we have put 6, fulfilled this. It's time for the next D. So 1 2 3 4 5 6 5 we cannot put, no, so we cannot put anything. Then we try to put 7. 7 is already used. Then we try to put 8 9, so we cannot put anything because we want decreasing. So again we do backtracking. Can I put 8 here? No, we cannot put 8. Can I put 9 here? No. 10 sorry, 10 is out of bound, so the only option is 9. So we have fulfilled this I. Then this D. Can I put 1 2 3 4 5 6? 6 we can put. Then we have fulfilled this also. Then it's time for this D. 1 2 3 4 5 6 no, no value can be put, so we will backtracking and again increment this. 1 2 3 4 5 6 we can put. Then on this location we are on to this. 1 2 3 4 5 no, we cannot put, so we will do backtracking. Try to put 7 no, 8 no, 9 no. Then we will do backtracking 8. Then 1 2 3 4 5 5 no, 6 we can put. Then on this location between 1 to 5 we cannot put anything. Then we again do backtracking 7. Then your normally option is 6. Then our I reaches this location. If we have we are on to this, if my I is equal to pattern length, then just return. So this is my smallest string that we can find. So this is one option, and other options can be found using this approach. But our first option is the minimum option. So what is this? 1 2 3 4 1 2 3 5 1 2 3 5 4 9 8 7 6. So let's check. So this is same as our output. So this is the expected output. Now let's code this. How we can code this? So first of all, 1 second. So let's code this. What we have? So we're gonna use a set. So I will create a global set. Okay, we can create inside a function set. So this is visited hash set, and we can start from any value. We can start from any value. So for loop between 1, so this is value between 1 and till 9 value plus plus, we can start from any value. We will call our function, and as we have used this, so just add this value. We want pattern, we want pattern ith index, we want our accumulated answer, then we also need visited. That's it. So we will do backtracking. If this solve function does not return anything, so this path is not possible, so we will do backtracking and remove. So I will create integer, but I will convert it into string. So let's take a very big number, because we want to find minimum. So I am taking very big number. So then just return, convert into string. So it's time to build this solve function. We have pattern, we have ith index, we have accumulated, so this is we can call current. Then we also have string, this is visited, not string, this is set. Yeah. So what is the base case? If my pattern, if my I reaches pattern length, so we will no longer pick the character. So this is pattern, so we have reached this, so just accumulate it between answer and current and return from it. Next we have different type of options between 1 to 9. If this number is already picked, if visited, this number is already visited. So let's say this is val. This is val. I is used for string index. This is val, and we have already picked this. Then if the value is already picked, so we are just gonna skip it, and then the current value is not already picked. So we have two different options. If pattern length, pattern not length, pattern ith character is equal to increasing, so we require increasing, we require the previous character to be smaller than current character. So how we gonna pick the previous character? How we gonna pick the last character from the current? How we gonna pick the last character, last value from the current? So we will just do mode. So current mode 10. So this is increasing, and our current value must be increasing than previous value. So we can write this thing here, and previous character must be less than current character. Current character must be more. Current character must be more. So we can go ahead. Pattern, jump to the next character and calculate this. So current multiply 10 plus value and visited. Else if pattern dot ith character is in decreasing and current value is decreasing, our current value is decreasing, so current modulus 10, our current value is decreasing, is smaller than previous value, so jump it and consider this. We are multiplying 10 because we want to consider it. So let's suppose in the given current we have value as 1. So if the value is 1, then if the ith character is the I, so we want increasing order. So we want 1, then we also want to append 2. So it will be 1 and 2. So it will be 12. So if we have given 1, so we will multiply it with 10 to get 10, multiply with 10 to get 10, and then we will add it. So that's why multiply 10 plus value to append the value, then visited. But one thing we have missed is if this value is already picked, so just ignore it. Else we are picking the value, else we are considering it. So just visit the value, and if that path is not possible, so just remove it. This is the backtracking part, and that's it. We're gonna get our answer, and we're gonna get our answer minimum. This is not minimum, we need to do math dot minimum. I hope it will work. Yes, so we can optimize this. How we gonna optimize this? So our first current will be our answer, isn't it? Our first character, our first smallest number will be our smallest answer. So why not just directly return true from it here? So if we are getting true from this condition, if we are getting true from the remaining string, so then we will directly return true on this point. If we are getting true, so just return true. No need to do further operations, and this is the smallest answer. Else return false, convert into boolean. If we are getting true, return answer. That's it. This is the optimization. We are no longer required to find each and every valid sequence, each and every possibility. We are just interested in the smallest possible answer. So just calculate your answer, then just return it. So this is more optimized, and now let's submit this. I hope it will work. Then we're gonna discuss about the time and space complexity. So yes, it's submitted fine. So then let's talk about time and space complexity. What we have? So we are trying to place 1 2 3 4 5 6, means 9 value on our first item. Then we are placing 8 items, then we are placing 7 items. So this is the possibility. So this is n factorial, 9 factorial. This is 9 factorial, which is I think 10 raised to power 5. So our time complexity is this. Our space complexity, so this is recursive. This is we are not utilizing any space. Yes, we are utilizing visited. So it will store order of n items in the visited, and recursive stack will also store some items. So the recursive depth of any path will be order of 9. So we can say it is constant space, and that's about it. I hope you learned something new. Give this video a thumbs up, subscribe to this channel, and thank you all for watching.